So now we're going to create a small interpreter to create programs that'll be strings of sequences. We're going to call this TurtleScript, a turtle language. And in our simple language, the syntax will be that we'll have a command separated by spaces followed by 0 or more parameters. The first part of this will be the lexical analyzer that'll take the TurtleScript string and parse it into tokens. And this is actually not the way computer programs and compilers are implemented. We're going to write this by hand, so it'll be simplified somewhat. Okay, so we developed a scripter in class. I'm just going to go over some of the design aspects for you. I think this will be useful for other people too. And basically, I created a file called Script Parser Java. And one of the things I thought about was I wanted to try to generalize this so I might be able to use this for other languages. So there's no dependencies here on the turtle class, but now the turtle class does have a dependency where it is required to know what a script parser is because there are turtle methods that run the script. So basically our script parser is going to be an array list, and we're going to use it as a queue, so we call it source buffer queue. And everything in the list will be strings, including the numbers, but then of course we'll convert those when we use them in the actual interpreter. So primarily the script parser is misnamed. It's actually a lexical analyzer, and normally if you were creating a new computer language, you'd use an automated tool like Lex that would generate the lexical analyzer for you, and you'd use regular expressions to specify. Our turtle language is really simple. It only has commands and parameters, and right now parameters can only be numbers, and we actually haven't worried too much about floating point numbers, so mostly it's ints. Okay, here's the constructor for script parser. And basically it takes the string, which is the source code or the program for our TurtleScript, and the first thing it does is it splits the string on the white space, the spaces, into an array, and then it feeds the array into the string buffer because we're going to use the array list, which is called source buffer queue. We're going to use the array list as a queue. Hopefully you know what a computer science queue data structure is. It's a structure where it represents like what we call in the United States a line. In Britain, that's a queue. And so if you're in a line to get on the bus or to get tickets, you get at the end of the line, and the first person in the front of the line is the first person served. So we call that a FIFO, first in, first out structure. And basically the operations that we want to do on this structure is we want to remove a token from the beginning, which if it's a command, then we want to remove all of the following tokens that follow it, which are parameters, and then we'll feed that to the actual interpreter. So the interpreter will take two parameters, the command and an array, which might be 0 length because some commands don't have parameters. Okay? Alright, let's just real quickly look through here. This is the constructor. It takes the sequence of commands, splits on the white space there, puts them in an array, then we go through the array and add them to our source buffer queue, and that's how we create a script parser. Here's a Boolean method, has token, which uses the size of the array list to determine if there are any tokens in it. We're going to use this has token in a while loop, which will basically consume the tokens one after another until we run through the entire script. Here's a debugging method that normally we won't use. I used it to develop the class, and so you can see what this does is it just dumps the token stream out. And it prints one token after another on one line, one per line with a tab at the beginning. Okay. The get token will actually return the token, which again is the string, and it'll remove it. So this consumes a token. And then the peak token method will return a copy of the token, but it'll leave it in the queue, the source buffer queue. And this is used for what's known as look ahead. So basically I can look ahead to see what the type is for the next token. These methods need a little bit of refactoring here. I want to use regular expressions here eventually. I haven't looked up the syntax for that in Java. So is keyword assumes that a command or a keyword is all letters. So this just loops through and makes sure that the token we just read is all letters. And when I say just read, we're just looking at it. Again, get is the peek function, not remove. And so what this will do is it'll tell you if the next token in the queue is a command or a keyword. And then this one does the same thing, but it looks to see if the token consists of all digits. And although we need to modify this to take a dot for decimal values, right now the simple language only supports parameters that are all integers. Now a true lexical analyzer does a lot more than this. So it returns keywords, operands, identifiers, things like that. So right now our simple language doesn't have any variables. It's all just commands and parameters, which are integers. Okay? All right, let's look at how we implemented this now in the Turtle class. So I've got the script parser, and so now I'll go over to the Turtle class. And if we go, we have two methods, run command and run command string. So let's go ahead and look at run command first. This is the simple method, and it basically takes a single command from our Turtle language and an array of the parameters, and notice those are integers, and then it goes through and attempts to run the command. And basically it assumes that you've already set up a turtle. And of course this is in the Turtle class, so you're running it on the turtle within a given world or picture that you created the turtle in. Okay? First thing we want to do is find out how many parameters we have. So that's the size or length in this case of the parameter array. And then this is going to be just a useful local variable to save creating a bunch of variables on the fly. You'll see how that works, but that'll work differently in each command. Okay, so basically if we look at this first command, the command string, which will be in the actual language, is di, and we've kind of followed that format here where these commands all have an initial capital letter, and if they have more than one letter, the rest of the letters are lowercase. And by the way, I notice here that I have a little typo there where the output. So all these work pretty much the same. Let's look at what this does. We have a switch, and actually rewrote this time because now, as of Java, I think 1.6, you can use string values here, where in the initial Java you used to only be able to use integers. So this is something I've taken advantage of for a lot of years in JavaScript, and I'm glad now that Java supports it. So this will switch on the command that's passed in. For instance, if we pass this di command to draw a diamond in, we'll see that it'll match this. It'll make sure the pen is down. It'll check to see if the param value is 0. Now if it is, then basically that's an error, because this particular command requires you to have at least one parameter, which is how long to make the sides of the diamond. And one of the things we've done with our language is we've implemented where a certain reasonable amount of default. So we have a global constant called default length, kind of like the Turtle library does. And so in this case, since the param value is missing, the move length will be the default. If the param value is greater than 0, which means you have at least one, then that means the move length is the parameter, and so then in this case the move length is what the user specified in the script as opposed to the default. Okay. Then basically, if we have more than one parameter, that's an error because we only need one. And actually, I just kind of noticed this is missing here, so we should add another value in that says if we have 0 parameters, that's also an error. Okay. So let's see. Let me think about this a second. I did this with the students, and it looks like we got the logic off a little bit. So if it's if the param value is equal to 0, oh, I see. So right here we're missing the system out statement. So sout tab system out print line missing param error on di command. Okay, so do you see that? If and what happens is it will print the error out, but then it'll go ahead and use the default. And then here, if we have more than 0, if we have just 1, we're good. If we have more than 1, then we have an extra 1. Okay, finally this comes down, and notice this command always works. So it'll go ahead and draw a diamond 3D using the move length, which is either the default length or the length that was passed in correctly as the parameter. Now this is a function that Leo Adams, one of my students, wrote, and it draws what looks like an isometric diamond, and this is the length of the sides. So it's actually a figure that has 2 tetrahedrons with a common base, which I believe that's an octahedron, yeah. So it draws an octahedron, and it kind of looks like an isometric. Okay, I don't need to run through all these commands here, but let's just take a look at a couple more. Here's the forward command, which comes in the Turtle library. Again, we put the pen down. If the parameter value equals 0, in this case that's not an error, and then the move length equals the default length, which is 100 pixels, just like in the Turtle library. Otherwise, if the param value is greater than 0, that means we passed in the length, and so that'll be the first parameter here, and so we set the move length to that. And then finally we check to see if we have more than 1, which means we had an extra parameter, so we do a little error message. But in either case, we go ahead and either move the default length or the length specified by the first parameter. Okay? Backwards is pretty much the same. This is the right turn method, and in this case, it's if it has any parameters, that's an error. But again, we just go ahead and turn right. So that's a 90-degree right turn, and in the language, that's just turn right. Okay, and you can see that we're calling that here. I didn't say that correctly. Not the language, in the Turtle class. So you can see how we've abstracted these methods from the Turtle class to be very simple commands that we can then combine in a command string. Okay, let's look at one that's a little more interesting. There's the PU for pen up, PD for pen down. PW is the width command, so that takes a parameter, which is the width. Oh, and move, basically, we have added a couple of commands. So here, move and move relative, so M and MR. And it looks like we have this, yes, so move relative can be represented as M with an R or a lowercase m. The reason I did that is the SVG language uses lowercase for relative commands. So move is going to expect 2 parameters, and you can see that here, and so we'll use the move to. And notice this is just a move command, not a draw. So we changed the language a little bit. Now we have a D command that draws and a DR which does a relative draw, and then we have move that just moves with the pen up, and then we have a relative move. Now the difference between the relative move and the move is the relative move adds a value to the existing X and Y position. So if you look down here in the relative move, when we move, it gets the current turtle position and adds that to it. So you can basically move relative and this can be a positive or a negative value here. You know, I didn't check that with a negative value. The parser might not support that because of the negative symbol. So we'll have to check and see if that works here. I might need to fix the lexical analysis that we looked at, the script parser. Again, that's really not a parser. I named that wrong. It's a lexical analyzer. Here's that draw method I talked about. So that does an absolute draw. And then you can also do a relative draw. And again, it probably won't handle a negative value. We didn't debug that completely. Let's see, what is PV? That's the polygon from vertex, our first polygon method. And that takes 2 parameters. And then here's the polygon from center, which I did in one of the videos. I guess I did both those methods in previous videos. And this one takes 2 parameters as well. Again, they're quite different. One draws a turtle starting with the turtle on the vertex of the polygon. The other assumes the turtle is at the center point where you want to draw the polygon and draws it there of the specified radius. Here's the vertex cloud, which is a method that I did. I didn't show you that. It's in the library, the turtle class, that is. What is this one here? Oh, that's another method I wrote called stellate, which kind of draws a polygon where the vertices are all joined together, sort of like a pentagram or hexagram. Let's see, what do we have here? This is a random flower. That's a method that I wrote. This is a different kind of flower, which is not random. I also wrote that. Basically what that is that's a common center point with segments that extend out for a fixed radius. And in the random flower, the radii are not fixed. They vary. And then this is a flower method that I believe Cody McPhillips wrote. And what it does is it takes a number of parameter values and it actually changes the color. So it's a pretty colorful type of method. It's pretty nice. Here's another method I wrote, which is based on polygon. It's a circle from center. And basically it just draws enough segments to make the polygon look like a circle. It has some conditional code in there depending on the size to try to optimize the drawing, because some of these things actually take a while. Here's the end, so if we get anything else, that means it's an illegal command in our language, and that'll actually break the program. So, well, not really, no it won't, but it won't do anything, and then it'll skip through. And so if it has any parameters, let's see, let me think about that. Yeah, that would probably be okay. So it'll just skip an illegal command and keep running. You can kind of tell from my way I'm talking here, we didn't debug this totally. So, okay, so I forgot. Let's go ahead and look at the script parser test that I built. And this is not going to draw anything. This just tests the parser. So this was a test that I did for the parser. I wonder what that is. Missing params tag for... Oh, okay. I usually don't bother with that. All right, so we create the parser. Here's a sample program. This is syntactically correct. It probably doesn't matter if you have white space at the end or not. So this says forward 10, then right, forward 10, then right, then forward 10, then right, then forward 10, then right. And again, that wasn't really a sufficient test here. We didn't test everything. I just wanted to test the basic parser. There's no turtle here now. This is just testing the script parser. So you can see we go ahead and call the debug token stream, which just displays all of them. Then we have a loop, and this is how we would use the parser. So it calls the has token, and this is basically going to consume tokens, and this while loop will run as long as there are tokens in the token buffer. And so then we'll just print out token, and we'll use the peek method to peek at what the token is and show it, put a tab, and then if it's a keyword, we'll say it's a keyword. If it's a parameter, we'll say it's a parameter. And then we'll print out to go to the next line, and then get token without anything thing over here just removes the token. So let me run this real quickly and show you the output. This is a console program. It's not going to do any graphics. And then you can see here is the output. So there's the first we have the debug where it just dumped everything, and then the for loop goes through and you see token F keyword token 10 param. That's pretty straightforward. So I mean, again, that's minimal debugging, but pretty much got proof of concept there. Okay, so I did want to show you that. Now let's go ahead and run our script test. And so here the TurtleScript test, I create a picture, create a turtle called Luke. I set all the pixels in the picture to yellow. I set the color to black for Luke to draw on. And then here we have Luke running several command scripts. So this is going to be pen width 2, put the pen down, go forward 200. Then we'll draw a circle on a center with a radius of 50. Then we'll turn 45 degrees. We'll go backwards 150, and then we'll move 100 to move to location 100, 100, and then we'll draw a vertex cloud with these parameters. And okay, so unfortunately I had an interruption, and this is probably going to be a little bit of a break here in the video, but I'm going to go ahead and try to salvage the time I put into it here. So as I was saying, I have a TurtleScript example here that I'm about to run and test. We actually call this twice. It should pick right up where it's left off in the first command. So let's go ahead and run this and see if it works or not here. So I'm going to use the run file command. And here's our simple TurtleScript. That, by the way, is the vertex cloud that I mentioned there. It's a method that I have in there. So, you know, not real sophisticated here. It's just a random test with a bunch of commands to see. But if you think about what I've gained here, this would be quite a bit of source code that I can now write with a simple script. And so I've really extended now what I can do with my Turtle library. And I can do a lot more now with the script. So for instance, I can create multiple turtles and have them run the same script. I can do that real easily, where that would have been kind of difficult to do with straight Java. So the TurtleScript is certainly not finished. One thing we could do eventually is get it as a full standing program, where we'd have commands to create turtles and create a picture, save the picture, all that stuff. And it would be kind of cool if we hooked this up to a website so people could write turtle scripts and run them on a website. And honestly, I don't know if I'll get to do that or not, but I just wanted you to appreciate what we could do by creating this interpreter.